let me get started with the evolution of the ISP. So most of us are familiar with the way the internet has evolved, and so was the ISP. The internet service provider primarily started off offering very basic internet connectivity. Back in mid 90s, ISP was all about providing bandwidth and providing internet connectivity. So people could use modems and dial up to a number and get connected to the ISP. Now, ISP 2.0 started offering some basic hosting to enable presence of online presence of businesses. If you remember, in India, this was very prominent with VSNL. Initially, VSNL was just an internet connection provider, and later on, VSNL started offering email IDs and also basic web hosting. Then the third version of ISP was all about co-location. So ISPs started renting out real estate space and rack space to enable businesses to bring their own servers and put them up in the racks of the ISP, and that could actually share the same infrastructure as of the ISP. So this enabled businesses to primarily move customer facing and public facing and even partner facing infrastructure, including servers and storage, to an ISP's environment, and that was called co-location. With that in place, many ISPs started thinking, why not offer certain models, certain applications under what is called as an application service provider model. So this is where if 3 or 4 customers are actually moving their servers running the same software, for example, an ERP or a CRM or a collaboration software, why can't the ISP set up the same server and provide it in a shared environment? So this was the seed for the cloud and SaaS, what we know as today. So application service providers were the next generation ISPs who exposed commonly used applications in a subscription shared environment. And eventually that led the ISPs to become cloud in their current avatar. But we haven't defined what is cloud. So all I want to summarize at this slide is ISPs are the logical cloud providers. They were offering basic internet connection earlier, then they offered hosting, then they offered co-location, then they brought in the application service provider model, and now they are set to become the next cloud providers. So this is one very important trend, the way the ISP has evolved. The next important evolution in the last decade has been the programmable web. So initially, the web was all about being static. Then it became dynamic, and as we know, there have been many portals and many websites. For example, when you use Bing, when you use Windows Live, Facebook, Twitter, Google, any of the popular portals, they not only deliver content or experience in the browsers, but they also expose APIs. And these APIs actually enable the new generation of applications to consume the capability. For example, today there are mobile applications that run within iOS, Android, and Windows Phone devices. So these applications provide a better user experience on the devices, but they talk to the same website. So this capability of going beyond the browsers and exposing the functionality of the web applications is possible through a set of protocols that have evolved in the last decade. For example, HTTP, XML, SOAP, REST, JSON. These protocols actually made it quite possible for the websites to really become programmable. So one way of thinking the current programmable web is that the web is a huge database, and every website is like a table, and there is a SQL to query each table, and that SQL is not really an ANSI SQL, but one of the protocols like SOAP or REST. And then JSON or XML are primarily the wire format protocol that lets you send queries and receive the response over the wire programmatically. So this has actually made the whole web as a huge data source, and that's how the web is being consumed today in various devices, including mobile devices, even televisions, and including the car entertainment systems. So that's the future of the web. Then the very important trend of the last decade is virtualization. So this has actually transformed the complete data center infrastructure of many enterprises. So with virtualization, many enterprises have been able to bring down the number of physical servers into just a few number of servers. So instead of running dozens of powerful servers consuming storage, power, cooling, and administrative resources to manage them, virtualization actually consolidates multiple number of physical servers into fewer number of servers, but the number of logical workloads would actually remain the same. So the virtualization infrastructure will enable uh, enterprises to deal with lesser number of physical servers, but actually more number of logical servers. So this has been a very critical trend that actually changed the face of IT in the last decade. So we actually discussed three different trends. The first trend is the way the ISP has evolved. The second trend is the way the web has become programmable. And the third important trend is virtualization. So these three have been primarily independent. These three were not interrelated, or there was no concentrated effort to actually drive these three trends together. But what really happened in the last 3 4 years is all these three trends came together to form the new phenomenon called the cloud. So what exactly is the cloud? Now let me step back a little, and I see that most of you are developers, and you understand the web services evolution. You understand how web applications are architected today. You have hardware at the bottom of the stack, which consists of the processor, memory, and the storage. Then we have an operating system at the next layer. And on top of the operating system, we install a language, an API, an SDK, and a server. So think of this as a LAMP stack. So you have Linux as an operating system running on a Xeon server, and then it's running PHP runtime with an Apache or an Nginx server with PHP API. So that's going to be your LAMP stack. Similarly, if you're running a Java stack, it's a Xeon server running an Ubuntu operating system with JVM as the runtime, JDK as the API, and Tomcat as the web server. And then on top of Tomcat and JVM, you actually have the web application written using JSF or structs or Spring or any of the frameworks, and that actually delivers the web user interface. But the same application can also expose SOAP or REST endpoints, making it possible to consume web services. So this is how a traditional web application is visualized. Now, every time you really want to deal with this, you have two choices. One, you could actually buy a new server, install the entire stack on it, or you could just hire some servers. In India, it's quite common that every time there is a training or a hands-on lab, it's quite common for us to go ahead and rent out some servers and some PCs, where we spend about 4,000 to 5,000 rupees a day to hire these machines, and then we'll send them back when we are done with the lab or the training program. Now imagine with internet connectivity becoming ubiquitous and bandwidth is becoming very affordable, when you want to hire PCs, you actually need not ship them physically. When you want to get PC servers, you need not really move them or port them physically. With the service provider or the company that is giving you computers on rent is connected to the internet, and you are connected to the internet, and you have netbooks or very low end PCs already in your environment, but you need powerful servers. So instead of taking the servers and PCs, putting them in a truck and sending it to your lab, the service provider can actually send you X number of IP addresses, usernames, or SSH keys as passwords. And then from inexpensive PCs, you can actually log into very powerful servers. So that's the first step in remote infrastructure, where instead of renting PCs on a physical basis, you are renting PCs or servers on a virtual basis. So today, how do I need to access any remote PC or a server? I just need three things. I need an IP address, I need a username, I need a password or the SSH key. As long as I have these three, it's fairly simple for me to access a resource, a server or a PC. So uh, now the new generation infrastructure service providers have figured this model pretty well. And what they do is, if you want to rent out servers or PCs, you can just place a request and they will expose the machine for you. Let's say they expose the hardware plus the operating system on demand as a service, and you get to access that from wherever you are. We can actually call this as a cloud operating system. But what exactly is the cloud? The analogy and the depiction of cloud goes back to early 90s. During early 90s, when distributed computing and client server was just becoming popular, the architects took the help of a small diagram which represented a cloud to depict a resource which is at a remote location. For example, when you are replicating two databases and one database is at a different site and the other database is at your premises, to depict that these two databases are separated by a network, the architects used to draw a small cloud, and that actually represented a resource which is remotely available, not visible, not in the line of sight, but still accessible. So that's what actually evolved, and now that has become more of a standard to depict anything that is remote, which is accessible but not visible, right? So when the operating system and the hardware are exposed to you, uh, that you cannot really see physically but you're still able to access, it is perfectly okay to call them as a cloud operating system. So now, instead of renting physical servers, you are renting servers that you can't really see but they are remote, so they can be qualified as a cloud operating system. Now, similarly, when the service provider gives you not only pre-configured operating system and machines, but they also set up web servers for you, and they install JDK, JVM on top of these virtual machines, and they give you the runtime plus SDK as a service. We can actually call that as a cloud FX. Cloud FX is a shortcut to cloud framework. So now, why do I call this as a cloud framework? Because I primarily get what I want. I have access to my JVM, JDK, Tomcat, but I never need to install them. I never need to configure my servers. I just need to take my var file and put it up in the appropriate directory, configure the web server container, and then just go live. So this actually reduces the pain of dealing with virtual servers or physical servers. And as a developer, will only move my code or my packaged application. So, for example, I could just move my var w3 HTML folder to the folder that the service provider gives, and I go live. So now the framework is also remote, and it is technically fine to call that as a cloud framework. Then we have the whole web application as a service. So this is actually the full-blown application, the full-fledged application. Not everyone is an IT operations professional. Not everyone is a developer. There are a lot of consumers of applications and IT. They don't want to deal with operating systems. They don't want to deal with the code, but they just want applications. For example, once in a year we file tax returns, and I just want an application which will take my form 16, uh, file my tax returns and sends me an acknowledgement. So this application, when it is designed using the same stack, but as a consumer I never worry about whether it is using Java or PHP or .NET, whether it's running 32-bit or 64-bit of an Ubuntu, whether it is running a Xeon processor with 4 cores, 8 cores. I don't really care about any of that, but I still consume an application, and that application is remotely available. So it qualifies to be called as a cloud application. Now, when I'm actually explaining this, you might think Hotmail as a cloud, Gmail as a cloud, or any other website as a cloud. That's not really the case. There are certain attributes, there are certain qualities, there are certain tenets that are applicable to the cloud, and only they qualify a resource as a cloud resource. So, more on that little later, but I hope you got a chance to understand how the world is moving from dealing with physical servers to dealing with remote resources, which are actually virtualized and exposed via programmable web protocols like HTTP, JSON, and REST. So, uh, if you're still wondering, what really has contributed to this, it's very simple. Let me put all the three trends together. ISPs who have evolved have started adopting virtualization and started exposing the virtual machines using standard web protocols. So these are the three factors that primarily led to the evolution of cloud. When ISPs implement virtualization and expose that virtualization over the public internet using JSON, XML, SOAP, and REST, you essentially have cloud. That's exactly what led to the cloud revolution. So that's the connection between those three factors and what we call today as a cloud. So let's put the official tag names or the nomenclature for the cloud services. So initially we dealt with the virtual machine and the operating system as a service. We call that as a cloud OS. So this is actually called as IaaS, infrastructure as a service, where you actually get to deal with the primary infrastructure, which are the building blocks of the core application. So this primarily deals with the hardware and an operating system and some processor architecture, memory configuration, the storage capacity, and so on. So when you're actually dealing with a service provider who offers you virtual machines with pre-configured operating system, you are essentially dealing with what is called as infrastructure as a service. Then there are additional players who actually offer pre-configured environment with your popular runtimes, APIs, and web servers so that you don't deal with the virtual machines. That is called as PaaS, platform as a service. Uh, Similarly, when you're dealing with a cloud application, that is actually called as SaaS, software as a service, where you're dealing with finished products where you never get to deal with the runtimes, the operating systems, and the hardware, but you consume an application like an end user. This is called SaaS. So this is how it basically aligns. Applications on premises are turning to be software as a service. The traditional word processors, the traditional CRM applications, ERP applications, even supply chain management, enterprise application, business intelligence, collaboration, all those models are now delivered as software as a service model. Traditional platform, .NET, J2EE, or Spring, or Ruby on Rails, or Python, PHP, now all of them have evolved into what is called as platform as a service or as a PaaS. Then the traditional way of procuring a server from a HP or a Dell, installing the core operating system and letting the IT team install rest of the software, that model is translating to infrastructure as a service. So this is how you primarily visualize or relate to the cloud services world. What does it really mean for you? Most of you are developers, some of you are IT administrators, some of you are managers, but what exactly cloud computing means to you? So for IT professionals who are primarily into installation, operations, management, monitoring, it is IaaS. So if you are an IT pro, you actually align with IaaS. If you're a developer, obviously you get to deal with platform as a service. And if you're a consumer, you only deal with SaaS, software as a service. So this is basically a quick recap of the cloud. Now, I want to take a quick pause and actually show you some live examples of infrastructure as a service and platform as a service and software as a service offerings. So here, let me start with one of the popular infrastructure as a service offerings called Amazon Web Services. So let's say my whole intention, my whole objective is to launch an Ubuntu server and install WordPress on it. So all I need to do is click on launch instance. And when I click on launch instance, this is going to show me a wizard, which is going to walk me through a set of steps. And here you actually see that Amazon is offering me core building blocks. I can choose multiple flavors of Linux. There is Amazon's own Linux, there is Red Hat Enterprise Linux called RHEL, there is canonical Ubuntu, there are various flavors of Microsoft Windows, all the way from 2008, 2008 R2, 2012, and configured with SQL Server and also with IaaS, and so on. Uh, so these are basically the pre-configured servers that you can launch with just few clicks. More on this later in the next webinar, where I'm going to talk to you about launching your first server in the cloud. Uh, this goes much beyond what you see here. For example, there's a concept of community AMIs, where the community has picked up the base images, the base virtual servers, and installed customized software. For example, here you'll see there are thousands. I'm currently in the Amazon Sydney region, and there are 1228 pre-configured images. For example, if I want to launch WordPress, it takes me just one click to launch a pre-configured WordPress server. And then I just need to port my application and I go live. So this is how you deal with infrastructure as a service, where your servers are now virtual, they are pre-configured, you just click and launch a server. This is just one example. I now want to show you one of the other platforms. Now what you see here is actually Windows Azure. So Windows Azure is also an infrastructure as a service platform. So here I can click on compute, select virtual machine, click on gallery, and here you notice that like Amazon, of course, limited in choice, but here I can launch a BizTalk server, fully configured, SQL Server, Windows Server 2012, CentOS 6.3, SUSE Linux, Ubuntu, and so on. Right. So this is the new phase of infrastructure where you basically select your choice of operating system, and then you basically choose the configuration. For example, here, if you are able to follow what is going on in the screen, you can choose a configuration. For example, an extra large with 8 cores and 14 GB memory is a very powerful server, and all this with just a few clicks. So this is infrastructure as a service. Now I want to walk you through how a platform as a service would look like. Now when it comes to a platform as a service, one of the very popular PaaS is actually called Heroku. And in Heroku, when you sign up and when you want to deal with it, their first promise is forget servers. You will never get to deal with servers. You'll only deal with what they call as dynos, right? Dynos are pre-configured containers which come with a variety of runtimes. For example, Ruby, Node.js, Clojure, Java, Python, Scala, and so on. So this is how you deal with PaaS. Here you don't get to deal with virtual machines. This is meant for developers. You basically push your code and just deploy your code, treat it like a developer. So this is basically the Heroku model. But that's not all. There is another platform as a service offering called AppFog, and AppFog is also a um, pretty popular platform as a service, which is just picking up the steam. It is based on what is called as Cloud Foundry. And here, when you're actually deploying applications, you'll notice that the model is extremely different from Amazon EC2 or Windows Azure VMs. So here, as a developer, I first get to choose my runtime. For example, I want to deploy Java applications. The moment I choose Java, AppFog prompts me, where do you want to run? And they support multiple clouds. For example, I want to launch a Java application in Singapore, Amazon. I'll choose this, and then I give a name. So when I actually provide a name, it goes ahead and creates an application for me. It uses 768 MB memory out of the 2 GB that's allocated to me, and I can launch multiple services. So here, I never get to deal with virtual machines. I only deal with my language runtime and the region where I'm going to launch, right? And similarly, there is Google App Engine, right, which is a very popular platform as a service. So here in Google App Engine, again, you will never get to deal with VMs. You will just deal with runtimes and environments. For example, Google App Engine supports Java and Python, right? So you can quickly push your code. If you are actually interested, follow my Cloud Ready webinar series. in the future, I'm going to walk you through each of these cloud platforms. One of my passions is to explore multiple clouds, and I'm going to bring you all these platforms that you're seeing here, and we'll actually go ahead and explore them. So this is a very quick real world references of IaaS and PaaS. So let's go back to our slides, and let's go to the next level of demystifying the cloud to really see what really defines the cloud. So there are four tenets of the cloud. If you are thinking Hotmail is a cloud, Gmail is a cloud, and my website hoster is a cloud, not really. Let me walk you through this. So let me do a quick recap of the definition. So cloud computing is about accessing your IT resources remotely, right? So IT resources could be infrastructure, could be platform, could be software, but when you are accessing them remotely, on demand, self-service, pay by use, you essentially deal with the cloud. So more on those attributes a little later, but that's primarily the quick recap of the definition we have seen in the previous section. So what really qualifies to be cloud? The cloud has to implement four key tenets, four key qualities, four key attributes, and four key rules to be qualified as the cloud. So let's take a look at elasticity. So the elasticity capability is the ability to shrink and expand, right? This actually provides what is called as the illusion of infinity. So this is an example of what really happens when you try to book your Tatkal ticket during the morning hours. Between 7:45 a.m. and 8:30 a.m. when you're trying to book your ticket, there is a lot of load on the servers, a lot of burden, and the servers give up. Now, uh, IRCTC can actually provision more number of servers to handle that, but what do they do with it after the Tatkal booking? Similarly, the university results. No one actually visits the university website during the normal days, during the normal academic year cycle. But when the results are published, every student actually goes to the university website to check his result. That one single day, the university website will have tremendous load. So, how can they really handle that? So, instead of investing in resources that go waste throughout the year, uh, these applications can enjoy elasticity on the cloud. So how does it really work? So when the load increases, the number of servers on the cloud automatically expand, right? So your application will now start to automatically replicate across multiple servers, and there is no limit, which is giving you what is called as the illusion of infinity. You can actually spin up multiple machines as and when the load increases. This is great for e-commerce portals. This is great for many contemporary applications where there is a lot of unpredictable spike. This is one of the benefits of cloud. Now think of traditional colocation or hosting. Uh, Adding another server to your application will take hours to days to sometimes weeks. Whereas in the cloud, it's a matter of few minutes. For example, on Amazon EC2, when you configure an auto scale, it hardly takes about 2.5 minutes to bring up another server, configure it, to adopt your application, and then join the application, join the server to the application, and now it actually starts addressing the traffic. So this is elasticity, the ability to shrink and expand on demand. So this capability is very unique to cloud. The next important capability is basically pay by use, right? In pay by use, with elasticity and pay by use, this becomes very interesting. So let's say you start with your cloud computing bill of $1, hypothetical, but as and when the servers get added, the service provider will start incrementing your bill, and during the peak hours, you might be running on half a dozen servers, and your cloud computing bill momentarily will touch about $6. But this is only for the peak loads. When the load reduces and when you start deprovisioning the servers, uh, what really happens is the cloud computing bill automatically decrements. So when you combine pay by use with elasticity, you will never worry about over investing or under investing, because uh, if you are committed to a 1 year contract with a co-location provider, your infrastructure is not optimized. during non-peak loads, 3 of your servers are sitting idle. And during peak loads, you need to add more servers. So it's unpredictable, and you will end up either paying more or paying less for what is really required. With pay by use, you'll only spend on your infrastructure as and when required. So this is going to really help many startups, because only if you make money, you will end up paying to Amazon or Google or Microsoft. And that's a great model. The next one is self-service. We have just seen an example of going through the launch wizard of EC2 or Windows Azure. So this actually puts the control to the end user. Gone are the days where you have to plead your manager or your IT team to give you a server with a lot of restrictions, and then deal with it with a lot of IT restrictions, policies, and so on. Here, if you have a credit card, you can actually go sign up for a trial version, quickly create a VM, deploy your application, try it out, fix it completely, then demonstrate it to your manager and convince him that this application, your idea works, and then either continue to run on the cloud or bring it back to your IT department. So this is a phenomenal attribute of the cloud. You are in the driving seat, you take the steering, you control the wheel, and you take the direction of your choice. So this is another critical factor of the cloud, which is self-service. Now, the other important aspect is programmability. This ability makes programmers superheroes, because programmers typically deal with the code that either powers the web application or talks to the database. But now, developers are very powerful because they can actually program the infrastructure, they can code the infrastructure. There is this new concept called DevOps, which will bring more power to developers and, of course, more power to IT administrators as well. But the advantage of programmability feature is, till now, developers have been using multi-threading. Maybe they are using multi-core programming. Now they'll deal with multi-server programming. What I mean by that is, your application can become so intelligent that it can automatically request the cloud service provider to provision more resources. You can automatically check if you're running out of disk space periodically, and when you know that your swap memory is going low or your root storage is shrinking, you can programmatically add another volume to your operating system, to your virtual machine, format it, and start moving your log files to it. All this automatically, without ever raising a support ticket saying that your swap memory is low or your root volume is shrinking. So that's the advantage. And with 4 lines of code, the developer can actually shut down the entire data center or can bring up a new data center. He can actually do, for each server in my data center, server.shutdown. And this is not hypothetical. Watch out for Cloud Ready webinar series. I'm going to bring you a webinar on programming the cloud, where we'll actually write program in PHP and Java to actually bring up servers, shut down servers, add more power to the servers, and we'll perform every task that the administrator performs through a console or through the command line, but from the code. So this is programmability. Again, no hosting environment actually provides you that. So the 4 key tenets of the cloud are primarily elasticity, pay by use, self-service, and programmability. So when compared to web hosting, this is a chart that actually compares cloud versus web hosting. So with elasticity, uh, it's available only with cloud computing. Web hosting, think of your favorite web hoster. He will take hours together to provision your new server. Pay by use, uh, it's very hard to achieve with web hosting or co-location, because you need to sign long-term contracts which will lock you down. Whereas in cloud computing, you only pay for what you consume. Self-service, it's partial, thanks to control panels like Plesk uh, and cPanel. You can actually do a little bit of self-service, but they are not as powerful as a cloud computing self-service paradigm. Programmability, there is no way that the web hosting or colo providers can give you programmability, because they don't deal with virtualization, they deal with bare metal. And obviously, programming the virtualization layer is far more easier than dealing with bare metal. So this is basically web hosting versus cloud computing. So I'm sure you heard of terminologies like public cloud, private cloud, and so on. So what exactly is public cloud? So public cloud is primarily a cloud that is available on the public domain. For example, we have seen Amazon, we have seen Azure, we have seen Google App Engine. Now, all of these are examples of public clouds. So I can create a resource, and if I share my credentials, you can pretty much log in and manipulate my server. In fact, in our business, our customers sign up for an account and share the credentials with us, and we deploy, manage, monitor, and optimize their Amazon resources or Azure resources. So that is public cloud. A customer in Europe creates an account, and we sitting in Hyderabad actually manage his resources. So that is a public cloud, and his servers are also public facing. All the web servers are accessible to the public unless we close the ports. So every resource that you create is by default available to the public domain, and you got to be selective in defining a policy to open up or close the resources to the outside world. Versus private cloud, which runs behind a firewall. This is exactly the same cloud, but this runs behind the firewall of an enterprise. This enjoys exactly the same capabilities. Private cloud is also elastic. It is self-service. It is pay by use and also supports programmability, but none of the servers are going to be available to the public domain. So, how does self-service work in a private cloud? What's the advantage? Uh, if you are working in a large enterprise, you know that dealing with IT department is not easy, right? You have to raise a prerequisite, a request, then it goes to your manager, it goes to his manager, and finally it goes to the IT manager, and then someone has to procure it. It goes to the procurement department, and by the time your server comes, it's going to be a few months. Whereas with a private cloud, organizations can provide a self-service portal, and every employee can basically go request for a new virtual server. And of course it still follows the same workflow, but without the bottleneck of procurement or actually placing a physical order with a hardware service provider. So this is going to be a great advantage in bringing the agility to enterprise IT. It also makes it easy for the CIO, the Chief Information Officer, to really understand which department or group of his enterprise is consuming more resources, and he can manage his cost centers and P&L better, because the CIO has better visibility into the IT investments and actually the usage patterns across the organization. Then comes in hybrid cloud, which is a combination of private cloud and public cloud, or on-premise data center and the public cloud. So not every application is meant to be on the cloud. For example, you might want to run a customer loyalty program on the cloud. Every time someone buys your product or subscribes to your product, you want to update an on-premise CRM. And this CRM is very critical. It actually relies on a lot of other line of business applications, and you can't really move this CRM application to the public cloud. So you still want to keep running CRM on premise, but run your e-commerce portal on the cloud. So you can securely connect your e-commerce application running on the public cloud with a CRM application running in the private cloud or your data center. And this secure pipe that connects your on-premise investments to the public cloud is actually called hybrid cloud. So this is going to make it very useful for enterprises to move resources back and forth, and also to selectively choose what resources will be exposed to the public world. So this addresses most of the security concerns. Amazon's virtual private cloud or Windows Azure's virtual connect, virtual networking, and Azure Connect address most of these scenarios. So, just a quick recap, the implementation models are primarily around public, private, and hybrid. There is a concept called community cloud, but that is not as popular as these implementation models. So, we are towards the end of this webinar. So, what we looked at uh, are the cloud service models. We discussed infrastructure as a service, where we looked at exposing the cloud operating system, cloud platform, and cloud applications. Then we looked at the key tenets. What is elasticity? What is pay by use? What is self service? And how is programmability an important factor? Then we looked at the cloud implementation models. We looked at public, private, hybrid, and community. Community, not really much, but I can give you a one-liner pitch on community cloud. Basically, it's a cloud which is not a private cloud, not a public cloud, but shared among multiple players. For example, RBI can set up a community cloud for all the nationalized banks in India, or the Aadhaar UAID project can create a community cloud for all the ecosystem players to choose a cloud infrastructure. So this is basically a shared infrastructure set up for similar entities or same vertical line of businesses. So that was a very quick introduction to the landscape of the cloud services world. If you are interested in learning more, I have an ebook called Demystifying the Cloud. You can visit getcloudready.com/ebooks, and you can download a book by the same title, Demystifying the Cloud. This is a third edition. I'm currently working on the fourth edition of this book, but this has a lot of explanation and much more descriptive, elaborate narration on each of the concepts that we touched upon. This video, the recording of this webinar, will be uploaded to cloudready.tv in a day's time. So if you want to pass on the link to your colleagues, friends, or you want to come back and replay it, this will be made available on cloudready.tv. This portal has many videos, tutorials for you to get started. So take a look at it if you haven't visited. And I want to let you know that if this interested you, you can certainly attend my next webinar, which is going to be very technical. Well, not so technical, but gets you started with the cloud with Amazon EC2. So this is going to be on February 16th, same time. And we're going to bring you everything related to Amazon EC2. So how do you get started? You can visit getcloudready.com/webinars, and you will see a link there for you to register. Follow the same process as you followed for this webinar, and you'll be registered for this. Thank you once again. And if you have questions, feel free to reach out to me. My mail ID is mail@getcloudready.com.